But anyway, this is 623, day 3 of chemistry. And most of you guys have got both your quizzes done. So all of your attendance is in. And some of you guys even took the test this morning and did pretty well. So grades are updated. If you are missing something, that means I don't have it either in my quiz report or you haven't done it yet. So I think I sent you a message if you didn't do a quiz and said, hey, what's going on? Remember that the quizzes from quizzes are and the attendance, because that's the work that we did that day. The class work you don't have to turn in, so I can't use it as attendance. So these two quizzes here, the scientific measurement and the classification of matter, these were the attendance quizzes. So if you don't do that, then I have to mark you absent. So make sure you're doing those. Just about everybody did this. There's only one of you I sent a message. And then there was a few of you who didn't do this one, but did do this one. And I left this one open for 2 days so that you could have plenty of time to do it. So make sure you're working on that. I'll put in the announcement in that morning, like what is today's attendance assignment, so you know what's up, even though it'll already be in the module. Right now, as you can see in module, in unit 2, it just has the PowerPoints and the lecture, another PowerPoint lecture. I'm going to put all the YouTube videos that are good for this unit in there today. And then I'll put in the quizzes for chapter 4, chapter 5, chapter 6 in there. And then I'll put some classwork, and then the worksheets and everything will be in there. I was hoping we would be in the citrus class by now, so I didn't have to basically make, almost half the class into a class that we're going to move away from, but that's what it is. So I'll propagate that in there. And so just remember that the quiz or that assignment that we're doing that day is how you get attendance credit. So you got to make sure you're working on those. If you already took the quiz, there was a mistake on one of the questions. I fixed it. You got more points if you got that answer wrong because of my mistakes. Don't worry. It's nice to be able to do that live. All right. So just like yesterday, you can type your question in the chat, or you can raise your hand. I'll unmute you. You can ask your question. So it's up to you. Are there any questions? So the math questions on the test are things, like what's the density of this? If you have the density, what's the volume? If you have the density, what's the mass? And then some basic unit conversions. If you have 100 centimeters, how many meters do you have? And then there's a couple like add and subtract these numbers, and then what sig figs do they have? Multiply these numbers, what sig figs do they have? There's a question on writing a number in exponential notation, so instead of like 6 million being this big old ugly number, you can just do 6 times 10 to the 6th, that kind of stuff. So as soon as you take the test, it shows you your grade. As soon as you take it. So for unit conversions, we're just going to be doing metric units. So the way the metric system works is you have what is called the base unit. And the base unit is what you're measuring, and it has a name. So if you're measuring mass, we use the gram. Grams are really small, so many of the times they'll talk about kilograms. If you're measuring volume, we use the liter. This has the symbol little g. This has the symbol big L. Now, in your everyday life, a liter's a lot. It's about a quart. So a lot of the times you'd be talking about milliliters. Most of our volume measurements that we use in real life now are in milliliters. They used to be in fluid ounces, which was a weird measurement that most people couldn't measure a fluid ounce if you asked them to. So we switched to milliliters. So a bottle of water you buy is probably 500 milliliters. If you buy a bottle of wine or a bottle of alcohol, it's usually 750 milliliters. We still use gallons. Gallons are 4 quarts, but it's very similar to 4 liters, but they're very similar to each other. And then we have 10, let's see, mass, volume. What am I thinking of? Oh, distance. There we go. Distance is the meter, which is little m. And a meter is a little bit larger than a yard, like 40-ish inches, bigger than that. But we use the meter for distance. A kilometer, you need a little bit more than 1.5 kilometers to make a mile. So those are the big 3. And then we also measure time in seconds. Now, we still use minutes and hours and all that kind of stuff. But if you want to get something smaller than a second, we say milli and centi and all that kind of stuff. And then we have temperature. Now, in metric system, we usually use the degrees C, but the most appropriate one is Kelvin, which there are questions on Kelvin on the test. So remember that Kelvin is just degrees C. All you do is just add 273 to it. What happened was when they were doing experiments in the 1800s with temperature, you have negative numbers in Celsius. You have problems with the math. The real life examples they were studying were noticing if they doubled the temperature in Celsius, things wouldn't double. They would just be a fraction of what would happen. So they figured out this 273 number. And when they switched to Kelvin, they noticed that when temperatures would change in Kelvin, that would represent the actual real life change. So the Kelvin temperature is the metric system measurement. Now, we don't really use it a lot in everyday life because the numbers are huge and because they are big. It doesn't really make a lot of sense to people, especially when talking about the weather. Today will be 295 Kelvin and tomorrow will be 300 Kelvin. Is it hotter? Is it colder? Kind of hard for people to understand. Those are some of the metric systems units we use. We're going to use other ones too. But basically, in our old system, if you wanted to go up and down, you had completely different conversion for every single thing. Like, for instance, in the inch, if you wanted to go smaller than the inch, you just started cutting it up into fractions, which is helpful in some ways. But if you wanted to go up from that to feet, this conversion was 12. Well, if you wanted to go up from that to yards, then this conversion was 12, right? No, it was 3. And so this was confusing. So back in the 1700s, they came up with the International System of Measurement, or the System International, which is some really bad French, which is why these are called SI units. And that's the metric system. So the reason why the metric system is so helpful is you have the base unit, which is either the gram, the liter, the meter. But if you want to go one bigger, so say you want to go 10 times bigger, 10 to the first, then this gets a new name. This was called deca. And if you wanted to go 10 smaller, this got a new name, which had a big D, and this one has deci, which is little d. Oops. And then, if you wanted to go 10 bigger again, you got a new name, hecto, which is H. And if you wanted to go 10 smaller, you got centi, and it has little c. Now what this did is it made the chopping up of every single unit into the exact same conversion. So instead of like inches going 12, and then feet to yards going 3, and then from feet to miles going 5,280, it's all factors of 10. And 10 factors of 10 are very simple to do mathematically because you're just moving a decimal around. And then the very important one, we have kilo, which is K. And then we have milli. Milli, which is little m. So in our daily lives here in the United States, we tend to use centi and milli a lot, and we tend to use kilo a lot. Don't use deca a lot, don't use hecto a lot. If you were to buy land in a place that uses the metric system, they would sell it to you in like hectometers, depending on how big it was, instead of like acres and whatnot. Your car has kilometers on it. The tire pressure, we measure pressure in something called pascals in the metric system. Pascals are really small, so they use kilo pascals. And when you take medication, you take it by the milligram. And when you take measurements in small measurements using like a ruler, like a foot ruler, that's in centimeters. We have bigger ones. You've heard of these before, especially in the computer world. This one's mega with a big M. And then you have giga, end of the night. Giga, which is big G. And then since this is the age of really fast computers, we're now into tera, which is big T. And then this one you've heard of, 10 to the negative 6th, is micro. That's this weird symbol. And then taken to the negative 9th is nano. Nano, which is just n. And then there's 10 to the negative 12th pico, but that's so small that it doesn't really matter. So when you're doing metric conversions, you're just going to be moving the decimal around. Let me show you. So say, for instance, you measure that your house is 12.0 kilometers away from your school. So you're interested in wondering, how many footsteps it'll take you to walk there. And say it takes you, your gate, is 1 meter. So the question is, well, how many meters is this? Okay. Now, there's a really easy way to do this, but you can also use the dimensional analysis way if you don't want to memorize this. So the dimensional analysis way is the math way. It's very simple. you're going to treat this like a fraction. Make it a fraction. And you're going to multiply it by a fraction that gets rid of kilometers and gets you into meters. And for this, you use that little chart we made right there. For every 1 kilometer, there is 10 to the third meters, or 1,000. So then this would be 12,000. Now, there's another way to do this, which is pretty simple. You draw the base unit, and then you draw 9 lines. And so, if this is the base unit, U, this would be deca, this would be deci, this would be hecto, this would be centi, this would be kilo, and this would be milli. We don't know the name of these, so we're going to skip those. This then would be mega, and this would be giga. I screwed up. And then right here would be micro, and then over here would be nano. So we were right here with 12 kilograms, or kilometers. And we want to go to meters. So we're going to take our decimal, and we're going to go 1, 2, 3. So we're going to take our 12, our decimal, and we're going to go 1, 2, 3. 1, 2, 3. And we get the same thing. So that's another way to do it. If you don't want to do the fractional, dimensional analysis, you can use that little line. Basically, you draw a line, 9 this way, 9 that way, and then you can do the conversion. It helps for a lot of people. So say, for instance, you wanted to know, you had 126 millimeters, and you were interested in how many kilometers that was. Well, that would be a couple of steps for our dimensional analysis. We would have to go 126 millimeters, cause that a fraction, and then we don't know the fraction from milli to kilo. We do know the fraction from milli to meter. For every 1 meter, there's 10 to the third of these. And now we can do what we did in the last one. For every 10 to the third meters, there's 1 kilo. So that means that we're going to divide this by 1,000,000. So 126 divided by 10 to the 6th is 1,000,000. Well, if we're down here, we can use our little method and just go 1, 2, 3, 4, 5, 6. So we move our decimal 6 places. So 126 becomes 1, 2, 3, 4, 5, 6 kilo. Which, if you put 126 and you divide it by 1,000,000, get the same answer. So that's metric conversions. That's all I'm going to ask you to be able to do. You can do it that way. What else you got? So for every concept that you had to do, there's 1 or 2 questions. So like we did the Kelvin example, where it's like Kelvin is equal to degrees C plus 273. So it's going to ask you 2 or 3 questions on that type of math question. We just did the unit conversions, so you'll expect 2 or 3 questions on that. We did significant figures, so you can expect 2 or 3 questions on that. That works. It's only a 30-question test, so we covered 2 chapters, so there's only so many questions we can ask about each topic. My philosophy on that is, say for instance you're struggling with like Kelvin. Well, if I put 10 questions on there about Kelvin and you get them all wrong, that's a larger percentage of the test that was based off of one concept. So I try and put many concepts on there so you can show your understanding for as many things as possible. And again, if you want to just say your question, you can just raise your hand up. You can even unmute yourself if you want. But like I said yesterday, if you're working through the worksheets and you're doing the quizzes and you're finding those easy, you'll find the test easy too. So I think 6 people have taken it already, and they all have A's and B's. There's no bad grades yet. Okay. Well, if you guys don't have any other further questions, we can cut it short, and you guys can spend the day working on your test. Don't feel bashful about asking me a question. I'm sitting here at my computer. I'm refreshing all the time so that I can see your questions, and I can come in and ask you. Remember that you have 3 hours to take the test, so take your time. Think about each question. But if that's it, then we can call it for today. Okay. Have a good one, guys.